Hello and I welcome you to my Eduventures. So today we will be continuing our special integrals 1.3 part 2. Now in the previous video, in the previous lecture, you have observed one thing, that it is very tough to converge all the questions of integration in a common form. In fact, there are many questions and hardly enough form to cover all of them. And the only way to get success in integration is sufficient practice. Now we cannot converge all the questions to a common form, okay, but we can intercept questions and bring them back to a particular form if we have sufficient practice on integration. So in today's video, you will be observing and you will be witnessing certain questions which are actually not part of the form we are discussing in here, that is of 1.3, but we can converge them and make them integrable. Okay, so let us begin. Alright, so our first question, integration of x to the power 4 divided by x to the power 4 plus 1. Now if we look at our form from the beginning, you will observe that we always recommend that the new method should have a quadratic term. But in our question, and also we have discussed in our part 1, there also we have also discussed that the new method should have a quadratic form. Okay, or even if we have a constant, then also it won't be any problem. But in our question, by looking at the new method, we can conclude that it is obviously not in our form. But as I have told you before, that it is very tough and almost impossible to converge all the question of integration in a common form. And this is one example. Now, what shall we do here? We will intercept it and convert to be integrable. Now, how to do that? Now, observe here. Let me add a 1 and subtract a 1 in the numerator, the denominator being unchanged. Alright. Now, if we separate the numerator with respect to the denominator, then we are going to have 1 minus 1 by x to the power 4 plus 1 dx. Alright. Now, if you split the integration, we are going to have integration of dx minus integration of dx divided by x to the power 4 plus 1. Okay, so the first part is integrable and the second, but the question is that in the second part, how should we integrate 1 divided by x to the power 4 plus 1? Okay, the answer lies in the form we have discussed in the last video. Now take a look here. Take a look at this integration. Okay, integration of x squared divided by x to the power 4 plus 1. Now let me do one thing. If I remove this x squared and in place of that if I place 1, then by simple logic we can also here remove, say let me remove this x squared and bring 1. So now you have to change certain terms here and bring a plus here, and again let me remove this plus and bring a minus. Alright, so that our left hand side and right hand side remains balanced. Okay, now have a look. Now if you observe here, then you are going to get exactly balanced left hand side as well as right hand side. Okay, in this manner we can integrate this type of form, and our question is exactly in this form. Alright, now let us do the same here. Okay, let me bring a half and then we will write x squared minus or plus 1 minus x squared minus 1. Okay, divided by x to the power 4 plus 1, the denominator will remain unchanged. Alright, now let us split the integration into two parts. So you will have half integration x squared plus 1 divided by x to the power 4 plus 1 plus half integration x squared minus 1 divided by x to the power 4 plus 1 dx. Okay, now the remaining part will be exactly same as we did in the previous videos. All we have to do is to divide both numerator and denominator by x squared. So you are going to get 1 plus 1 by x squared whole divided by x squared plus 1 by x squared dx. Similarly in the second part. Alright, now we will be forming completing square in the denominator. The numerator will remain unchanged as it is. Okay, so in the denominator we will have x squared. Now observe that In the numerator we have plus, so we will be forming a completing square using minus. So minus 2 times of x into 1 by x plus 1 by x square, and you have to remove this 2, so plus 2. Similarly, in the second integration, plus half of integration, the numerator will remain unchanged, and in the denominator you will write x square plus 2 times of x into 1 by x plus 1 by x square, and now remove that 2, so minus 2. Okay, so that's it. We have the form. Alright. Now, all we need is to substitute. Look at the denominator. It has taken the shape of x minus 1 whole square, plus we can write here root 2 square, and in place of numerator we will write d of x minus 1 by x. And as I always ask to verify yourself. Okay. Alright, similarly in the second part you are going to get x plus 1 by x whole square minus root 2 square and d of x plus 1 by x. Again, verified. Alright, so we have the integration in integrable form, so directly we can say that its form will take us to 1 by root 2 tan inverse x minus 1 by x by root 2, and in the second part you are going to have 1 by 2 into 1 by 2 times of root 2 log of mode of x plus 1 by x minus root 2 divided by x plus 1 by x plus root 2 plus c. Okay, so that's it. You can stop here, but I think we should go a bit further and simplify. Okay, so we will have that's it. So this is your final answer. Okay, so we have reached our question number 4, the last question of the video. Now observe here and tell me, does this question actually resembles our form? Definitely no. Because if you observe all the form that we have discussed, okay, we have initially stated that the quadratic term should not have the x term. Okay, if you remember that the quadratic form should not have the x term. But it's the complete opposite. We have the x term. But as I have said earlier, that many questions may not resemble the form, but we can intercept it and convert to the form. Now, what should we do here? Now, observe here carefully. Let me separate the numerator as x squared plus 1 minus 5x divided by x to the power 4 plus x squared plus 1 dx, and split the integration into 2 parts. X squared plus 1 divided by x to the power 4 plus x squared plus 1 dx being the first part, which will be integrable obviously because now it resembles the form, and this is the second part. Okay, 5x divided by x to the power 4 plus x squared plus 1 dx. So the first part we don't have any problem with that as it is resembling the complete form. So we know that what we should do here, we should divide the numerator and denominator by x squared. So you are going to get here x squared plus 1 by x squared in the denominator. Alright, and in the second integral, what should we do here? Now observe that we have a linear term in the numerator, and till now we haven't got such form. And again, now let me convince you that every question does not resemble a form. So here what we will do, we can take x squared whole square, so that after substituting you are going to get the numerator. Okay, now the first part, let us form the completing square, x squared. So here we are going to take minus 2 times of x into 1 by x plus 1 by x squared, and you have to add a 2, and we have a 1 from beforehand. Alright, so this is our first integration. In the second part, if we take d of, or let me do one thing, let me take here x square equals to t, so that you don't have any confusion. So you are going to have x dx equals to dt by 2. Now let me replace x dx by dt by 2. Alright, divided by, you are going to get t square plus t plus 1. So as you can see here, we have moved to the form of 1 by quadratic. Alright, so integration, the denominator we know what it has to become. The second part, here we have to use again completing square. Now let us see. So t square plus t plus 1. We will have t square plus 2 times of t into half plus half square minus half square plus 1. So we are going to have t plus half whole square and plus 3 by 4. Let me put that. So almost done. We are going to get here. So I have applied only the formula, nothing more. Okay, now let us simplify and end the result. Alright, so that's it. This was our final question for today's video. But the most important thing is that you have learned that only through practice you can converge a question to a known form. Okay, there are not many forms but plenty of questions. So I hope you are practicing well at home. So let me end the video with this. And if you are benefiting from our video, like our video, subscribe our channel so that you get timely notification of our uploaded videos. Thank you.